We're asked to rearrange these sequences here, A and B, by increasing size of these particles. Let's do A. We'll do the atoms here in blue and their anions in red. So we know as we go down the periodic table, atoms get larger. So sulfur and oxygen atoms are in the same group. So oxygen is smaller than sulfur because oxygen has two energy levels of electrons and sulfur has an extra energy level of electrons. So there's more shielding going on to put those valence electrons farther from the nucleus. We know sulfur is larger, so put that here up on the right side and oxygen over there, and we'll work on the other ones now, the ions. When these, I'm gonna have to move this guy. All right. When atoms gain electrons, oxygen has 6 valence. They both have 6 valence electrons because they're in group 16. Well, that's how you know the last digit of that group number. Now, when they both gain electrons, which they'll both want to gain 2 electrons to achieve the octet rule, when they do that, they're going to get bigger, much bigger, because those 2 added electrons now increase the repulsion of all the other electrons. And not only that, because electrons are negatively charged particles, they repel other other electrons. And not only that, there's more electrons sharing the same number of protons. Right? So the number of protons did not change. For oxygen is going to be 8 and the sulfur is 16. So for 16 electrons that sulfur used to have, now it has 18 electrons because it gained 2 to look like argon. It's those now 18 have to share the same 16 that are in sulfur. So it's going to balloon much larger. All right, so the largest of all of these in that list is going to be the sulfide ion. It's going to be much bigger because it has gained, I don't draw that again. Right, it's going to gain that it's going to have much more repulsion. So now the question is, where is going to be so this is the 2 negative sulfide anion. Now where is this oxide going to be? Is it going to be there or is it going to be there? And now this is not something we would ask you on a test because you'll have to consider 2 things. Number one is the oxide ion has 2 energy levels, right? But they're less attracted to the nucleus, and they have greater repulsion to each other. And the sulfur atom, the neutral atom, has 3 energy levels, but those valence electrons are more attracted relatively than oxygen because it's got more protons and the electrons out here don't feel as much repulsion because they didn't get any additional electrons added. So it turns out this repulsion is much greater than the added energy level of sulfur. It's actually the oxide anion, I think, is about the same size as, I think it might be even bigger than selenium. Okay, so that's a much greater effect, and we wouldn't ask you anything like this on your test to choose between the repulsive factor of adding electrons versus the added shielding from extra energy levels. Right, we would choose one or the other. We wouldn't ask you to compare both. All right, so your answer to A is this is going to be the smallest. This is going to be the next smallest. There, and then this is definitely going to be the largest. All right, now let's go on to part B. Now you can try this in a similar fashion. It looks like they're giving us the same. Oh, these are cations now. All right, so this is kind of backwards. These are metals. All right, so we've still got 2 atoms. I'll do that in blue, and then we'll do the cations here in green. All right, again, they're right on top of each other. So as you go down the periodic table, you know atoms get bigger. So what was it? Oh wait, it's right up there on the sodium versus potassium. So potassium is going to be larger. I'm going to do that down here. All right, so we know potassium is here, is the larger of the two, and sodium is smaller, simply because potassium has more energy levels. It's bigger. 3 versus 4. It's just, all right, sodium's got 1 there, and then these are all full, all that shielding, and there's potassium. All right, so what happens when you remove an electron? Okay, when you remove an electron, atoms get smaller for the opposite reason. When you remove that, now that whole energy level is gone, and the remaining electrons, which are fewer, are even greater, have even greater attraction for the nuclear charge. So cations are always smaller than their parent neutral atom. Even if you're not losing a whole energy level, they're just much smaller because they're just each remaining electron has more of that nuclear charge to itself. So we know the smallest is going to be the sodium cation. That's just certain because it has lost that. This whole thing is gone, so it's hopefully you can see, right? This has 1, 2 energy levels. And it's even smaller than neon because it has fewer it has more protons and the same number of electrons as neon. All right, so now again the question is the potassium ion, is that going to be with the 3 energy levels? Well, this one's a little bit easier, right? It has the same number of energy levels as the sodium neutral atom, right? But this one's got each electron remaining has more protons, more protons. This one has a greater Z, right? Sodium's 11, potassium's 19. Okay, so it has 8 more protons than sodium. All right, now this is going to be smaller. We need to switch this around. All right, so your final answer is going to be the sodium cation. It's going to be the smallest, and then the potassium cation, because that has way stronger nuclear charge, and then sodium atom, and then the potassium atom. This is going to be the order of smallest to largest.